MIT published a list of 12 possible endings for artificial intelligence, 12 distinct futures for human civilization shaped by how AI develops, who controls it, and what decisions get made in the next decade. Most public conversation about AI risk has collapsed into two poles. Either AI saves humanity or AI destroys it. Those two outcomes represent the extreme edges of a much wider map. The 12 scenarios MIT researchers have identified span a range that runs from genuine flourishing to something researchers consider worse than extinction. Not more dramatic than extinction, worse. That distinction matters, and most people have never heard it framed that way. The reason is structural. Public discourse about AI tends to concentrate at the edges, the utopian and the apocalyptic, because those narratives are easy to communicate, easy to monetize, and easy to argue about. The middle of the map, where the majority of MIT's scenarios actually sit, is harder to explain and receives a fraction of the attention it warrants. That gap has consequences. The scenarios most likely to define the next century of human life are the ones least examined in mainstream conversation. The decisions that will determine which of those scenarios materializes are being made right now by a small number of institutions with limited public input and no global consensus on what the acceptable outcomes even are. The 12 scenarios exist. The question is, which one is already in motion? The MIT framework emerged from a sustained effort to move AI risk analysis beyond binary thinking. Rather than asking whether AI will be good or bad, MIT researchers asked a more precise question. What are the distinct structural futures that advanced AI could produce, and what are the conditions that lead to each one? The result was a categorization of 12 possible trajectories, ranging from outcomes that extend and enhance human agency to outcomes in which human agency is permanently and irreversibly curtailed. Each scenario is defined not just by what AI does technically, but by who governs it, how it is distributed, what values are encoded into it, and what institutional structures exist to constrain or direct its use. The framework reflects a core premise. The technology itself is not the primary variable. The decisions surrounding the technology are. Two identical AI systems deployed under different governance structures, different ownership models, and different ethical constraints produce radically different civilizational outcomes. MIT researchers treat those governance questions as the actual subject of AI risk analysis, not a secondary concern to be addressed after the technical problems are solved. This framing was on display at the inaugural Big AI MIT conference held on November 15, 2024, which drew more than 300 participants from academia, finance, and industry. The conference, co-hosted by MIT's Initiative on the Digital Economy, Thinkers 50, and Accenture, identified the primary roadblocks to what it called safe AI adoption. The list was not dominated by concerns about superintelligence or autonomous weapons. The leading concerns were operational and institutional, training millions of workers with new AI skills, scaling AI deployments from pilot programs to enterprise-wide implementations, correcting AI-generated misinformation and bias, and the persistent difficulty of identifying AI's financial returns with any precision. Those problems are not exotic, they are not science fiction. They are the conditions defining AI deployment in 2024 and 2025, and they map directly onto the middle scenarios of the 12-part framework, the ones that do not involve extinction but do involve significant compounding harm. MIT Media Lab formalized a complementary structure in October 2025 with the launch of SAIPian, the Scalable AI Program for the Intelligent Evolution of Networks. The SAIPian initiative introduced what it called an AI spectrum framework, a systematic approach to ethical and systemic AI development that spans human AI experience architecture, data governance, privacy preservation, and contextual reasoning. The program was designed not to predict which future arrives, but to build the institutional and technical infrastructure that could influence the outcome. The 12 scenarios are the diagnosis. Initiatives like SAPian are the proposed treatment. The gap between the two is where civilization currently sits. The catastrophic scenarios in MIT's framework include the ones that dominate public imagination, AI systems that develop goals misaligned with human welfare, autonomous weapons that escape meaningful human control, AI-enabled authoritarian surveillance that eliminates political freedom at scale. These are the scenarios that generate book deals, congressional testimony, and open letters signed by prominent researchers. They are real risks. They are not, however, the scenarios MIT researchers consider most alarming when examined carefully. The framework includes at least one category of outcome that researchers describe as worse than extinction, and the logic behind that claim is worth following precisely. Human extinction is final. It is catastrophic by any measure, but it is also, in a specific structural sense, complete. There are no survivors to govern, no populations to oppress, no long-term suffering to administer. The harm ends. The scenarios considered worse than extinction in the MIT framework are those involving permanent, stable, and self-reinforcing systems of human subjugation in which AI acts as the enforcement mechanism for a permanent hierarchy. In these scenarios, a small class of humans or institutions uses AI to lock in its own dominance with a thoroughness that no prior technology could achieve, and the resulting condition persists indefinitely, not for decades but for centuries, because AI provides the surveillance, the predictive enforcement, the resource allocation, and the behavioral modification tools necessary to prevent any organized challenge. Extinction produces zero future suffering. A permanently stratified civilization governed by AI-enforced hierarchy produces suffering continuously across generations with no mechanism for escape or reform. That is the calculus MIT researchers are applying when they identify certain non-extinction scenarios as categorically worse. An AI safety researcher quoted in the 2026 documentary, The AI Doc, described the development of artificial general intelligence as the last mistake humans will ever get to make, framing AGI not as a singular catastrophe, but as an irreversibility threshold. Once a sufficiently capable AI system is deployed under conditions that allow it to shape its own governance environment, the window for human correction closes. That framing applies equally to the extinction scenario and to the permanent subjugation scenario. What both share is irreversibility. The catastrophic scenarios, then, are not defined primarily by body count or destruction. They are defined by the elimination of humanity's ability to course correct. That is the line MIT researchers have drawn, and it runs through both the obvious catastrophes and the ones that look from the outside like a functioning civilization. 10 of the 12 scenarios occupy the space between utopia and catastrophe, and 9 of those 10 receive almost no sustained public attention. They are not invisible. Elements of each appear regularly in academic papers, policy documents, and think tank reports, but they do not generate the cultural momentum that the extreme scenarios do, and as a result, the decisions that would steer toward or away from them are being made without the public pressure that major choices of this scale require. The middle scenarios share a common architecture. In each one, AI develops and deploys in ways that produce significant benefits in some domains, while simultaneously producing significant and often irreversible harms in others. The benefits are concentrated, the harms are distributed. The institutional structures designed to address the harms lag years or decades behind the rate of deployment. One cluster of middle scenarios involves economic displacement without adequate social restructuring. AI automates large categories of labor, not all labor, not overnight, but steadily, sector by sector, while the institutional systems designed to redistribute the gains and retrain the displaced workforce fail to scale at matching speed. The big IMIT conference in November 2024 named this problem explicitly. Training millions of workers with new AI skills was identified as a primary roadblock to safe AI adoption, not a secondary concern to be addressed later. When the leading AI and economic institutions in the world identify workforce transition as a top-tier risk, that is diagnostic information about which scenarios are actively developing. A second cluster involves the compounding of existing social disparities through AI systems trained on historically biased data. These systems are not malfunctioning. They are performing exactly as designed, optimizing for outcomes defined by datasets that encoded prior inequities. Credit allocation, hiring, medical diagnosis, predictive policing, and content recommendation all operate through AI systems that have demonstrated measurable bias against specific demographic groups. The correction mechanisms exist in theory. They have not been implemented at scale. The big AIMIT conference identified correcting AI-generated misinformation and bias as another primary roadblock. Present tense, active problem, unresolved. A third cluster involves information ecosystem collapse. AI-generated content at sufficient scale and sufficient quality degrades the shared epistemic foundation that democratic institutions require to function. This is not a future risk. The conditions for it have existed since at least 2023, when large language models capable of generating plausible misinformation at industrial scale became publicly accessible. The scenario does not require a single catastrophic event. It requires continued drift, continued deployment without governance, and continued institutional failure to establish reliable standards for what counts as verifiable information. What makes these middle scenarios particularly consequential is their gradualism. They do not arrive as crises that trigger emergency responses. They arrive as slow accumulations of individually manageable problems that, in combination, produce civilizational scale outcomes. By the time the aggregate damage is visible, the conditions that produced it are deeply embedded in infrastructure, economic incentives, and political systems. MIT researchers have mapped these trajectories precisely because gradual scenarios are the ones most likely to go unaddressed until addressing them becomes structurally difficult. The 12-scenario framework is, in part, an argument that the absence of a dramatic AI catastrophe is not evidence of safety. The honest assessment of current AI trajectory requires separating what is measurable from what is projected. What is measurable? AI capability gains have been steep and consistent across multiple domains between 2020 and 2025. Large language models have moved from generating coherent paragraphs to passing bar examinations, writing functional code, and performing at specialist level on medical licensing tests. Investment in AI infrastructure reached hundreds of billions of dollars annually by 2024, with no leading economy treating that investment as optional. Deployment has outpaced governance in every major jurisdiction. No binding international framework for AI development existed as of 2025. What is also measurable? The gap between AI capability and AI accountability has widened, not narrowed, during the same period. The Big MIT conference in November 2024 found that the difficulty of identifying AI's financial returns remained a primary obstacle to enterprise adoption, which means that economic pressure is driving deployment decisions while the basic questions of whether those deployments are producing value remain unanswered. Systems are scaling before their effects are understood. The trajectory that current conditions most closely resemble is not the catastrophic extinction scenario. It is not the utopian flourishing scenario. It is a compound middle scenario in which AI produces genuine capability gains in specific domains. Those gains are captured primarily by a small number of institutions and nations. The social costs are distributed across broader populations without adequate compensation or restructuring, and the governance gap compounds over time into something that is much harder to close than it would have been in 2023 or 2024. The AI Spectrum Framework, introduced by MIT Media Lab's Sapien program in October 2025, identified the key structural variables: human-AI experience architecture, data governance, privacy preservation, and contextual reasoning. Each of these represents a domain where current practice falls short of what the framework identifies as necessary for a trajectory toward the more favorable scenarios. None of these gaps are technically unsolvable. All of them are institutionally unresolved. The trajectory is not fixed. Trajectories never are until they are. But the conditions of 2024 and 2025, steep capability gains, concentrated ownership, governance lag, unresolved bias and displacement, and no binding international coordination, are the conditions that MIT's framework maps onto the middle scenarios, specifically the ones defined by compounding inequality and eroding institutional capacity. The two scenarios most discussed publicly, AI salvation and AI extinction, are both, by the framework's own analysis, less probable than the middle paths. The most likely future is not the most dramatic one. It is the one being built incrementally by thousands of individual deployment decisions, each of which seems manageable in isolation and collectively constitutes a civilizational choice no single institution has made explicitly. The MIT framework is not a prediction. It is a map of conditional outcomes. Each scenario depends on decisions that have not yet been finalized, policies that have not yet been enacted, and institutions that have not yet been built. The range of outcomes still available in 2025 is narrower than it was in 2020, but it remains wide enough to matter. The Sapien program, launched by MIT Media Lab in October 2025, represents one model for what deliberate structural intervention looks like. Rather than focusing on a single regulatory lever or a single technical fix, the program addresses AI development as a systems problem spanning four interlocking domains: how humans and AI systems interact at the design level, how data is governed across its full life cycle, how privacy is preserved as AI systems become more capable of inference from aggregated data, and how AI systems reason in context rather than optimizing for narrow metrics that produce perverse outcomes at scale. Each of those domains corresponds directly to a failure mode in the middle scenarios. Human-AI experience architecture addresses the deployment of systems without adequate attention to how humans actually integrate AI into decision-making, a failure mode that produces automation bias and the erosion of human judgment in high-stakes domains. Data governance addresses the conditions under which AI systems encode and amplify historical inequities. Privacy preservation addresses the surveillance infrastructure that the permanent subjugation scenarios require to function. Contextual reasoning addresses the optimization failures that produce systems performing well on benchmark metrics while failing in real-world deployment. The Big MIT conference in November 2025 2024 identified workforce transition as a primary challenge for safe AI adoption. The policy response to that challenge is not technically complex. It requires investment in retraining programs, restructuring of social safety nets, and redistribution mechanisms that capture some portion of AI-generated productivity gains and direct them toward affected workers. The policy mechanisms exist in various forms. The political will to implement them at scale has not materialized in any major economy as of 2025. That gap between the known interventions and the implemented interventions is where the scenario selection happens. MIT's 12 scenario framework is ultimately an argument that this gap is not inevitable. The conditions that produce the more damaging middle scenarios are not natural laws. They are the accumulated results of individual institutional decisions about investment priorities, deployment timelines, governance structures, and accountability mechanisms. The window for influencing those decisions is not permanently open. Institutional path dependence is real. The longer a set of conditions persists, the more deeply embedded it becomes in infrastructure, economic incentives, and political systems, and the higher the cost of changing course. AI governance discussions that happen in 2025 or 2026 will influence conditions that persist for decades. The same discussions happening in 2035 will have fewer options available and higher transition costs. The 12 scenarios MIT researchers have mapped are not equally probable. The current trajectory of deployment, governance, and investment points toward a cluster of middle scenarios defined by concentrated benefit, distributed harm, and compounding institutional lag. That trajectory is not the worst available. It is not the best, and it is not final. The decisions being made now in corporate boardrooms, regulatory agencies, university research programs, and legislative chambers across more than a dozen countries are the decisions that will determine which of the 12 scenarios becomes the actual history of artificial intelligence. Most of those decisions are being made without the public understanding of what they collectively add up to. MIT published the map. The territory is still being built.